I need to give you a formula. Let me see. Make sure I give you the exact way we're going to do it. Let me grab my notes here. So, yeah. All right. So here is the formula we will use. A equals P1 plus R over N to the NT. So you no need to memorize that. You can put it on your 3x5 card. I'll probably have it at the top of exam 3 as well. Can you tell my R's from my N's? This is so this one's an R, and these guys are N's. So A is the amount at the end. P is the principal, meaning the amount invested. That's a good way to say it. Let's say amount invested. Yeah. The amount invested. The R is the interest rate. And the N, now what is N? N is the number of compoundings. Am I on the screen? Okay. Compoundings. Yeah. Compoundings per year. So in other words, if they say monthly, that means N is 12, because that's 12 times a year, right? Or if they say semi-annually. What's semi-annually? Twice a year, right? Yeah. So 2 times. Semi is half. So twice a year, or what else? Those are the main ones or then they'll just say annually, which is just once a year. N equals 1. So those are the kind of daily. I think if they say daily, they'll tell you 360 or 365, because different financial formulas use different. Sometimes they use 360. They'll tell us when we need that. All right, so so there's the players in the game. So this is really just a put in the numbers, hit the buttons on your calculator kind of thing. So, all right, so I'm going to use the formula that they've given me. I'm going to plug in. What is the 500? That's the P, right? 500 is the P. 1 plus R over N. The R is the 4%. Make it a decimal. 0.04. What is the N? Oh, compounded quarterly. So quarterly, 4 times a year, right? N is 4. 4 times a year to the NT, 4 times in 3 years. T's the number of years. I should have written that one. There we go. So T is the number of years, R is the interest rate, N is the compoundings per year, the number of compoundings per year. So there's the formula, it makes sense. 500 parentheses, 1 plus 0.04 over 4 to the power 4 times 3. We good? So that's hit the buttons on your calculator. 500, 1 plus, I think it's 0.01 to the 12. Whatever, you don't even need to figure out intermediate stuff. Just hit the buttons. Make that power 12, though. Make that power a 12. That'll be easy. And then hit the button. Somebody got an answer on that one? Tim, you got something? 563.41. That sounds reasonable. Anybody else getting that? Nobody? Anybody? Yeah? All right, good. So that must be the answer. A couple of us are getting that. So $500 invested. So what that means, $500 invested at 4% interest compounded quarterly for 3 years becomes $563.41. Good on that? Questions? You able to get that in the calculator? If you're in trouble with the calculator, grab me after class. We good? Can I move on? No questions? All right. I will move. I'll put it over to the other screen here. Okay, so try that one. Same kind of formula. A equals P1 plus R over N to the NT. Let's go ahead and plug in that one. N is 365 on this one because it's daily compounding. So $400. And it's 4 years. So there we go. Anybody getting it? Tim?
469.4.
0.40, just 0.4 straight?
Yeah.
Yeah, they want me to round to the nearest cent, so that'd be 40 cents. Anybody else getting that? So that must be it. $400 invested this way grows to $469.40 after 4 years. Make a whopping $69 in 4 years. Is that okay? Questions I can answer? Be good with the calculator? All right, so here, let me let you try that one first. So go ahead, give that one a try. $50 invested, 11%, compounded continuously, period of 2 years. Now, what's the N?
2 years. Yeah, no, 2 years. 2 years.
Well, T is number of years. T is 2. Yeah. What is N representing? N is number of compoundings per year, right? Like monthly, that'd be 12. Quarterly, N is 4. How many? Daily, it was 365 times a year.
There is no N in this one.
Kinda, huh? Continuously. That means like infinity, right? It's compounded an infinite amount of times to realize we need a new formula. So I want you to get that rather than me just say, hey, you need a new formula. I want you to see why. Does everybody see why? How do you know that we need a new formula? Well, right there, compounded continuously, N equals what? How can we do continuously? How many times per year is continuously? Well, when you get compounded continuously for continuous compounding, you need a new formula. And what you need, instead of, it's going to start out saying A equals P, E to the RT. Actually, E gets involved here. That special number, right? Like pi is a special number, E is a special number. It's used for continuous compounded interest. So that's the formula you use when they say continuous compounding. So how do you know which of the two formulas to use? If they have continuous compounding, you use the PERT formula. If they have any other kind of compounding, you use the other formula we've been using. So now the rest is the same. Just A equals P, the principal is 50. The E is just E. R, what's our 0.11? And T is 2 years. Yeah. So hit the buttons on your calculator. It's like 58, 59, 60. 62.30 or just 3 straight? 3 up. $50 becomes $62.30. Y'all getting that okay? So when do we use the PERT formula? Continuous compounding. Good. Am I racing you through? I'm just looking at that 26 total questions, wanting to keep on moving. We good? Okay. $700 after 2 years at 4% compounded monthly. Try that one. Let me let you try that one. So we just say, all right, so A equals P1 plus R over N to the NT. The 700 is the amount, right? Because you want to get 700, right? The A is the amount you get later. So that's the 700. We're trying to solve for P. The R is, what, 4%? Monthly means 12. N is 12. T is how many years? 2 years. All right, so there we so you just basically divide by this whole thing, huh? So just divide both sides by 1 plus 0.04 over 12 to the 24th power, huh? And you'll have P. So the principal's got to be something lower than $700, doesn't it? Right? That'll grow to become 700, right? 700 is the amount we want. Like you're saving up for some $700 purchase. How much you have to put in the bank now that'll grow to become 700? So what is it? 600 something?
646.27.
You mean the negative, your comments are negative in that one?
No. No, just do it just like I have it on the screen. It'll work fine on that. Yeah, Robert, the other way to do it, you're right, would be just to take 700. You're thinking this, huh? And you're right. Multiply by 0.04 over 12 to the negative 24. Right? Well, because you're probably confusing with that. Because now there's 12 times negative 2 for the time. And you're right. That's going to work too. Why? Why is Robert right? Why is this going to come out the same as this?
It's the same thing.
Because it's a negative.
Negative power jumps into the denominator. See? All of this negative power, negative 24 power will be the same thing as 24 on the bottom, huh? So that's a nice observation. That's another way to do it. If you want to be tricky, that'll do it too. Yeah. All right. Not required though. Our way's fine. There we go. Good. Questions on that? That's good just to see all those math rules agree with each other. You learn them deeper that way. All right. Okay, so this one's saying find the effective rate of interest of 5.25% compounded quarterly. All right, let me give you the explanation for what we're even talking about with this whole thing. Basically, the big idea is this: the more frequently you compound money, the higher your percentage rate actually is. I'm thinking of doing some refinancing stuff with my house, and I was looking at interest rates online the other day. I don't know if you ever noticed. You look at them, and it'll say like. What are they at now? For a 15-year loan, they're at 3.5%, but then it'll say APR like 3.58 or something. I don't know if you've ever seen that. It'll say, here's the rate for a 15-year loan. Here's the rate for a 15 if you want to refinance your house. And then but over here it'll say APR is 3.58. A little bit different. What is that? That means really in the end, you're paying 3.58%. It's listed at 3.5. But the actual effect on your money is a 3.58%. That's what we're trying to calculate on this problem. Effective rate or annual percentage rate. It's the same, two names for the same thing. What are we talking about? Like why is the effect different than the listed? Well, why are they different? What is that? Well, it's because you're compounding the money more often. For a home loan, it's every month, right? 12 times a year, every month. So it makes it a little higher than the listed rate. For example, let me just work out by hand. You don't have to do this at all, but I think I want you to get the idea, and this is where I'll spend way too much time. Quickly, but as I like this stuff and I want to be real and not just give you magic formulas. So think about this. Let me do a really simple numbers just to give you the feel for what we're talking about. Suppose I'm going to take like, I don't know, let's say $700, and I'm going to put it in the bank at 10% interest. Okay? 10% interest. 10% annual, like meaning one time a year, you know. So at the end of the year, how much interest am I going to get? 70, but you would just take 7, we don't need any magic formulas, right? I'm just going to do, again, you don't even need to write this down. If you can write it if you want to. This is not the method we're going to use, but I just want to appeal to you logically, make sense out of this, explain to you why APRs are higher. So 700, 10%, $70 interest, right? That's what would happen. Simple, right. Okay, now, what if instead they said, okay, instead of 10% annual, we're going to pay you 10%, let's say, semi-annual. Now, what does that mean? 2 times per year, right? Semi is twice a year. Semi means half, so we're going to compound your money halfway through and then at the end of the year, right? Or like a semicircle is half circle, right? So a semi means half. So whereas the annual means 1 time per year. So I just did the 1 time per year, 10%, got $70 interest. What does it mean if they say you can invest in this account, we're going to pay you 10% semi-annual? 10% semi-annual. Now it doesn't mean they're going to do 10% twice. That would be way more. That means they're going to do 5% twice. So it's like 10%, but they did it twice. So first off, you got to know what they even mean by the language. So they mean do 5% 2 times. Now you might think, well, that's just the same as 10, but it's not quite. It's actually a little better than 10 because well, let's see it. So notice halfway through the year, they're going to take my $700 and they're going to give me 5% interest, which will be like half of the 70, right? So that'd be $35 in interest, right? So far so good. Halfway through the year, they're going to hand me $35 in interest. Now it seems like, right, okay, then the second half, they hand you the other 35, it's 70, it's the same. No. Second half of the year, you now have in the bank not 700 but 735 because they added $35 to your interest. So now with the second compounding, it's actually on 735 5%. So you see it's going to go a little higher. Somebody have a calculator? What is 735 times 0.05? 3675. 30. So the second time you get 3675 instead of just 35. Add those two up. What is that? 7175. I just added 35 and 3675. Right? 7175. So I actually got paid a little more interest than I did at they're both called 10%, but the second one is 10% done twice, really meaning 5% done twice. So that's what they mean. So if they were to list this 10% semi-annual, they would want to figure out, really, we're paying you a little better than 10%, right? Because 10% would have just given you $70. We're giving you 71, 70. In fact, let's figure out a rate. What is that rate? How would you figure out what is 10% done twice a year? What rate is that really? Well, you would just need to say, I got 71.75 divided by my original 700. Right? So what is that? What is, I'm running out of room on this screen, but what is 71.75 over the original 700? That'll tell me what rate I was really paid. What is it? 10.25. So really, that's a 10. 10.25 is the APR of 10% done twice. It's the real effect of 10% done twice. A little better than 10%. Does that make sense? So when they list rates, 10%, 20%, whatever, and they say, like for a house loan, it's monthly, meaning they're going to do that, broken into 12 little pieces, but really that gives you a little more. Or if it's a loan, it's costing you a little more. Then if it's an investment, you're gaining a little more. If it's a loan, you're losing a little more. Either way, it's a little more than the listed percentage. And the more frequently they compound, like daily, that's going to have, not dramatic, but even a little more percentage on that. What's that? Right. This is all compounding interest. That's right. That's right. Which is all what they always mean for car loans, home loans, all that's all compounded. So, all right. So with that in mind, we're not going to do all this hard work. I'm going to give you a snazzy little formula just to whip out the answer. But I want to give you the big idea. That's what we're doing. That's why APRs are not exactly the same as listed rates when they're done. Well, let me give you a test question to see if you're really getting this idea. Here's a conceptual question. If I said, how about this? If I said, this will tell you how deeply you're getting the idea. What if I said 10% done, let's say quarterly, and 10% done daily, and this will be 10% done semi-annually, and this will be 10% annually. Okay, tell me now, if I go over here and I say, I want to know the APRs. These are the listed percentages, but what is the real annual percentage rate? That's what it stands for. The real effective rate is the other word. So what would be the first one? Does everybody realize that one's going to be the same? That's the part I want to make sure. Well, the next one's going to be something higher. I don't know. Maybe like 10.03. And this one will be like 10.04. I'm just guessing. I don't know what the calculator would say. 10.05. I'm just totally guessing. But my point is the first one will be the same. Does everybody realize that? If they're only doing it once a year, then it is what it is. But if you're doing it more than once a year, more than annually, then it's going to be a little higher. The more frequently you do it, the higher it'll be. Everybody getting that big idea? All right, so now how do we actually crank these out? What actual formula do we use? Well, I'm going to show you the easy way. This is a lot easier. I'll show you what they do something crazy. Anyway, the easy way to find APR, or effective rate, same thing. You're finding out what really happens to the money. here's what you do. You just put in, this is Mr. Heron's, they do a crazy way in the, what's called, show me an example thing. Really, really hard. Put in $1 for 1 year. Right? If you want to know what really happens to the money, then just stick in $1 for 1 year. Because what happens to that dollar is going to happen to every dollar. So just put in $1 for 1 year to whatever formula, you know, either the PERT or the other one. Same two formulas. No new formulas here. Same two formulas we've always been using. Put in $1 for 1 year. When you get your answer, take your answer and subtract the original dollar. So now you have the growth or the interest. Right? If you take out your original dollar, then you've got the interest, what it went up by, the growth, right? And then turn it into a percentage. Move the decimal, right? 2 places. And you got it. There's the 3 steps. That'll be way easier than the crazy stuff they have you do, if I remember right. Unless they change their plan. So put in $1 for 1 year. This would be a good thing to put in your 3x5 card for the next step. Put in $1 for 1 year because it's different than what they say. Answer and subtract the original dollar. Now you have the growth. Turn it into a percentage. Okay, so let's do it. I'm going to erase this stuff I have up here, and we'll just do the problem right up here. Which are we using, the PERT formula or the other formula, the first formula? Yeah, the first. This is not continuous, is it? So we're just going to use the PERT. We'll do the PERT. So, I mean, not the PERT. 1 plus r over n to the nt, same old formula. And I'm going to say, okay, I'm going to put in $1, so the principal is 1. Put in $1. Interest rate, oh, what is it, 5 1/4? Yeah, make that a decimal. You guys okay with making that a decimal? You know 1/4 is 0.25, huh? Right? If you're rusty, just take 1 divided by 4 in your calculator, right? 1/4, 1/4, 0.25. Percentage, so move the decimal back 2 places. That's 0.0525 over n. What is n? Quarterly. This is compounded quarterly, 4 times a year. See, see how the formula is doing exactly what I showed you with the 10% thing? See how it's breaking the interest rate by 4? See, that's why we divide by 4. We're saying we'll give you this rate in 4 little pieces. That's why we're dividing by 4. To the 4 times t. And what's t supposed to be? 1 year, because that's what I'm saying. Just put in $1. See, that's why the p is 1 for 1 year. The t and the p are both 1 because we're just putting in $1 for 1 year. Hit the buttons on the calculator. Let me know when you got it. It's going to be 1 point something.
05.
What is it?
05.
Oh,
1.05.
give me a couple more.
354.
That's probably enough right there. Yeah, so 1.05, 354. You guys getting that? We all good? Is that right? Oh, actually, give me one more. Sorry. 354, 2. Okay. So we good to there? I'll show you why we need some in a second. So here's put in $1 for 1 year. Take the answer and subtract the original dollar. So just get rid of that dollar. Because that dollar was the original dollar that grew to become $1 and some change, right? All I care about is the change, the 0.053542. That's the growth, right? Now take that decimal and go boom, boom, 2 places. 5.3542%. And they want me, I think they said round to 3 decimal places. So that would be 5.354%. There it is. That 5.25 account really is 5.354 APR. That's the real effect of your money. That's what's really going to happen to your money every year. We call it annual percentage rate because annual, 1 year. That's what will happen to your money after 1 year. There's laws now that say when they make loans, they have to tell you the APR. So you know the actual effect on your money. That's why they have that on the website. Not out of the goodness of their hearts, but they're required to by law. So they show you this. So when you read APR, you think that's what will really happen to my money in 1 year. Annual, 1 year. That's the real effect. Right? The 5.25, that's quarterly. But after 1 year, really your money will grow, or if it's a loan, shrink by 5.354%. Make sense? Questions on that? We good? All right, try number 12. I always remember continuous compounding interest because my oldest son, who's at state now, he took pre-calculus from me just like at home. I would just give him the book and give him the Math Excel program, and then I would just give him tests. And I remember testing him on this section and grading his continuous compounding interest problem on the test. So there it is. It's on the next test. And he did all this crazy stuff. I remember going to my son afterwards and go, Daniel, what is this? What is all this crazy stuff you're doing on it? And said, Dad, that's what they did on the program. I'm like, really? So when they looked it up, they used to have even a crazier explanation. I'm like, just put in $1 for 1 year. Just stick $1 in there. $1 1 year. So put in $1 1 year. $1 1 year. Hey, which formula are we going to use on this one? Yeah, continuous compounding, huh? Continuous compounding. So we're going to use the PERT. We're going to use the PERT. So put in $1. $1 P equals $1. T equals 1 year. So $1. And the rate is 0.08 1 year. What do we get there? 1 point. What is it again? 1 point. And one more, please. 9? Okay. So there's now, and then what do you do with that? Remember, that's what the $1 has become, right? So then you get rid of the original $1, because that was not, so the growth is just the 0.08329. Right? Everybody good with that? And then you just turn it into a decimal. Into a percentage. Move the decimal 2 places. 8.329%. Oh, what was after the 9? Oh, it was 8.7. So you guys are rounding right for me, yeah. 8.7. So that does round to 9. There we go. 8.329, that's the APR. That's the real effect of 8% compounded continuously. Meaning, in 1 year, annual percentage or APR, your money will grow by 8.329%. That's what will really happen. Every dollar will grow by 8.329%, the real effect. Good on that? Questions on that? Just $1 1 year, no. Okay, so they're saying, hey, which one of these is better? And so basically you figure out the APR, or the effective rate, either name. So 5% compounded daily. So daily we're going to use the A equals P, 1 plus R over N to the NT. And so, I'll move this another way. And then that's going to be $1. What is R? It's 5%. In daily, 365. And time is what? Oh, 1 year. $1 1 year. Somebody got that number there? 1 point. Guess I'm being kind of quick.
1.05126.
Thank you. Okay. Get rid of the original dollar. Move the decimal 2 places. 5.126%.
Make it 1.27%.
Rounds. Okay. Yeah, I think it's good either way. All right. So it rounds to 0.127. Okay. Now, what is 5 1/4? Let's compare that now to the other one. Yeah, that's just straight 5.25, and it's already annually, so it already is APR. It's already annual percentage rate. So therefore, just compare 5.25 to 5.127. Which one's better? Yeah, the bottom one. That's the larger amount, 5 1/4. Yeah. So the daily compounding makes it grow a little bit, but it still doesn't. It's not a lot. It doesn't pass 5.125. Good on that. So whenever they want you to compare rates, they're basically saying do APR. That's how you know how things really compare, because that tells you the real truth, the real effect of the money after a year. All right. All right. All right, so what rate of interest compounded annually is required to double an investment in 20 years? So let's write out the formula. We're going to use the PERT or the other one? It's the first one, huh? It's not, because it's not continuous compounding, so we're just using the first formula. Now, how do we do, what are they talking about doubling? What do I do with doubling? They're not hardly giving me anything. You want your amount to be 2p, right? You want it to be double the principal. Double the principal that was invested, huh? If you want your money to double, you want it to be double what would the principal. You want the A to become 2p, don't you? Does that make sense? That's what doubling means. You want your amount to be twice the principal that was invested. And then the R we're trying to find. N is annual, so N is 1. And T is 20 years. So we have 2p. Oh, actually, what are we going to do right away with the p's? Divide them out of there. Bye-bye p on both sides. So we have 2 equals 1 plus r over 1 is just r to the 20th. We good to there so far? Am I going too quick? See what happened? So I put in 2p for the amount. And r over 1, that's just r. 1 times 20 is just 20. Okay, now I'm supposed to solve for r, the interest rate. How do I solve that question for the interest rate? What am I going to do to get r alone? Oh, actually, no, it's not a log because the letter's not in power. There are powers, but the letter itself has not climbed into power. Just 20 through, or 1/20th power on both sides. Yeah, good. It's almost, yeah, because in a minute I think we will have some of those.
Yeah.
So let's put that in our mind right now. That when the letter gets into that power zone, that's when we'll do ln on both sides, huh? When the letter itself. But if there's just a number up there, you don't need ln. You just do, you just raise both sides to the 1 over that. 1/20th power, which is the same as the 20th root, if you prefer. Whatever way you want to say that, it's the same thing. 1/20th power, 20th root, same thing. That'll cancel it out. And so, coming over here, I guess, we have 2 to the 1/20th is 1 plus r. See how it got rid of the 20th power? So if the power is just a number, just raise it to 1 over that on both sides. Cancels it out, subtract 1. So 2 to the 1/20th minus 1. You guys get your calculator? Whatever 2 to the 1/20th minus 1 is, that's the interest rate. What is that? 3.5? Getting that? Give me a little, it needs 2 decimals, so 3.526. So basically you got 0.035 at first, right? Is that what you're telling me? And then you moved it over. Good job. Yeah, 0.03526. Move it 2 places. Perfect. 3.526 percentage. Or they wanted 2 places, huh? So 5.3, I guess. They said 2 places. Anybody else get that? Is that the answer you guys getting? So there it is. That makes sense on that? So remember those 2 cases, because in a minute they're going to let the letter get into the power zone. When the letter gets up there, that's when we ln both sides to get letters out of power. If it's just a number up there, we do 1 over that number for both sides to get rid of that. All right. No questions? You okay if I'm okay? All right. So now we're talking about A equals P, 1 plus R over N to the NT again. Because it's not continuous. Oh, the second one is continuous. I'll do the first one. The first one's monthly. I'm just going to do the 7% monthly. But for part 2, you would need the PERT formula because it's continuous, right? It's 2 questions in one, really, right? First, they're saying, how long for 7% monthly? And then they're going to say continuously. I'm not going to do part 2. You would just use the PERT formula. All right, here we go. They want double, so that's 2p. The rate is 7%. Monthly is 12. Good to there? Everybody good to there? What do I do now to solve? Get that p out of there. So 2 is, nope, p gone. Is 1 plus 0.07. I'm just going to leave 0.07. Because I don't think it's nice. I think it's an ugly. Is it? What is 0.07 divided by 12? Is it nice? No, it's not nice. Right? It decimal goes on forever. In other words, by not nice, I mean the decimal goes forever, doesn't it? Yeah. So I'm just going to leave. Yeah, when you have decimals that go forever, I just leave it as a fraction. It just seems easier. I don't want to. I don't want to round partway through a problem. That could throw things off. So I'm just going to leave it. All right, anyway, I got to solve that for t now. How am I going to solve for t? ln both sides. Here it is, right? When the letter is in power, right? Letter is in the power. You ln both sides. Yeah, that's the deal. That's different than the last problem. We just had a 20, a number in the power. So I just did 1 over 20 power to both sides. But when there's a letter in power, you have to ln both sides. Because then that power comes down. It's the greatest quality of the logs that they bring the powers down. So what do we got then? We got ln of 2 is 12t ln of 1 plus 0.07 over 12. And now, how do we solve for t? Just divide. All that's just multiplied. Did I just bump it? Okay. Just divide by the 12 and the ln of 1 plus 0.07 over 12 on both sides. I'm just totally out of room here. So divide by, on both sides, 12 ln of 1 plus 0.07 over 12. The 12s cancel, the ln's cancel. T is alone. Hit the buttons on your calculator, all that big old mess. It'll tell you T. Anybody got it? How many years? It's going to be right about, it's a rule of 72 if you've heard of that. Hold on, don't tell me the answer. It's going to be just over 10 point something. 10 point, I'm betting. 10 point something. There's a rule, the financial people know, there's a rule of 72. For money to double, you take your interest rate times your time, and it always comes out to be about 72. So I'm looking at my interest rate of 7, saying 7 times what is 72? What's the closest number? 10, about 10. 7 times 10, sometimes 11 would be 77, that's too big. 9.9, so it's close to 10. 9 point, yeah, it's just a rule of thumb. It's just a rough estimate. So 9.93, how many places do they want? 2. 9.93, is that right? So close to 10. There's a rule of 72 for doubling money. Good on that? Does that make sense? Questions on that one? So that might be one of the toughest ones. Whenever that letter gets into the power zone, ln both sides, right? Word problems are long. So let's do 18. Let's try that one. What interest rate compounded monthly will yield an effective rate of 3%? Let me let you think about it for a second. It's easy to get confused. We do so much, and I'm throwing it at you so fast. There's a key word up there that needs to jump off the page for you. So you know, like what are we even supposed to do? What are we even talking about? Effective interest rate. That's APR. Yeah, so that phrase has to be kind of magic for you. Effective rate. Go, oh, it's an APR problem, which means put in $1. What's a big dollar sign? Put in $1 for 1 year. It's one of those kind. See how recognition is a lot of the battle on a math test, huh? You see that key word has to jump off the page for you. Effective rate. Oh, it's one of those APR problems. So they want me to put in $1 for 1 year and that whole thing. It's one of those. Okay. Which formula are we going to use? The normal ones. Monthly. So A is P 1 plus R over N to the NT. All right. Put in $1. And what's the rate? Oh, that's what they're asking for, huh? What's the monthly is 12 and 1 year. So put in $1 for 1 year. Yeah. This has got a trick. We're running out of time. Do you see where we're at so far?
What would the 3% use?
Yeah, I'm going to do it. But we all up to here so far. We good to there, right? It's $1, 1 year. P is 1, T is 1. $1, 1 year. P is 1, T is 1. And the N is 12. Yeah, what do you do with the 3%? The A is 1.03. Why? 3% APR. They're telling me the APR is 3%. So if $1 grows 3%, it becomes 1.03. You see? Right? If a dollar grows 3%, that's 3 cents, isn't it? 1.03. That's the A. That's the amount it becomes. They're saying, hey, I want an effective rate. I want some lower percentage that's going to be the effect of 3%. So it's going to make my amount become, my $1, right? I'm putting in $1 1 year. It's going to become 1.03. So we have to solve that equation for R. Well, we're out of time. So, you would have to raise to the 1/12th power like we did those other ones. All right, this is not due. We didn't quite finish it up.